Okay, so the last two sets of videos went over the basics of dictionaries. We're going to go a little bit deeper with this. So let's suppose we have a bunch of names of students, their year in the program, and then their most recent 3 course marks. So we could use a structure such as this. We could have a list here that we call students. So notice we've defined this using list brackets. And then we have these nested lists here. So each of these nested lists pertains to a particular student. So the first student is Dan. He's in year 4, and here's his 3 most recent marks. Of course, those are yet another nested list within the list that's specifically Dan's list. And then Jose, year 2 with his most recent marks. I'm sorry, Joe. And so on. Okay. However, there's some problems here, and it's a little too restrictive in certain ways. We're imposing order on the elements. So why is the year 2nd and the marks 3rd? Does it really need to be? Do we have to always reference them in that order? That could become cumbersome, especially when you have a lot of pieces of information to record. The elements themselves don't have names, even though they should, right? Because they pertain to particular students. So we'd like to be able to call that element Dan, but we can't because this element here does not have a name. And there's no really nice way to print out these results. They're stored in an object, and we could go and retrieve particular parts of this object, this list object, but it's not convenient in any way. And what if we have students that are first year and don't have any course marks? Do we leave this blank? What do we do? It's not really obvious. Okay, so this is yet another case where a dictionary might be a very useful tool for us, and we're just going to step it up a little bit more complex structure than we saw last time. So if we use, instead of a nested list, we use a nested dictionary, we can use strings instead of indices to refer to our students. That's way easier than having to remember Dan is in index 1. We just remember Dan's name and so forth. However, there's still no flexibility within this kind of nested dictionary structure to support different kinds of students, such as the theoretical first year with no marks. Okay. Also, there's no way to ask a student to say, I want to pull out the average marks for Dan. There's really not a way we can do that right now in a really explicit, easy way. Of course, I could extract, so I could use the key of Dan. I could then extract the key for marks and then run a function for the mean on those values. So I could do it that way, but that's really, really not straightforward at all. Okay, so we're going to talk about here why at times we have complex enough data structures that we need to use our own classes to organize those data structures. So sometimes in Python, those built-in objects really don't support the kind of data we need supported. And I think this previous example was a really good one of that. And what we can do instead of just trying to work around it and having these kind of awkwardly designed data structures is we just define a new class. We're going to be adding, in essence, a new type to Python. Then we can make objects of that type, which we might, for this example, call student. If you recall, if you have taken the R portion of this course, we did the exact same thing in R. We created classes of objects so that we could have a very particular way that information was stored, information was presented. This is no different than that. Class names are nouns. They're going to be things like student or course, rectangle, animal, ship. Methods are going to be actions. So things like move, turn, teleport, lower shields, raise shields. I got lost there. Okay, so let's just remember that class names are nouns, methods are actions. That's the only rule we really need to know at first. And um, so let's think about other kinds of things we need to define before we define our first class. Is an attribute is just a feature or some characteristic of an object. It's not an action. A method, if remember, is an action, but an attribute is not. It's just like something about the object. An attribute is something that an object has, not something that it does. So let's say we have a class name we define as ship. Here's some possible methods. Well, a ship, this is very basic, guys, so don't read too much into this. A ship can move, it can turn, it can shoot, it can dodge, it can raise shields, it can lower shields, it can teleport, if you're in Star Wars. Possible attributes are things like the weight of the ship, the length of the ship, the width of the ship, the direction, the number of bullets. So notice there are not things it does, but things about it. Okay, let's make sure we understand because we're going to apply this in just a second to classes, which is a lot less concrete than the ship example. Which of the following is not a possible method for a car class? So remember, methods are actions. So which one is not a possible method? Well, which one's not an action? It's pretty easy, I think, here. Open a window, action. Accelerate, action. Num wheels, an attribute. The rest of these, action, turn right, apply brakes, action. So C, number of wheels is an attribute. Okay, same vein here. Which of these is not a possible method for a person? Well, the same thing. From the bottom up. Jump, walk, speak, climb stairs, all actions. Hair color, attribute. Okay, so now that we've got our terms in terms of the name is a noun, the method is an action, and the attribute is something about it, okay? Now when an object is created, there's these double underscore keywords within Python, and these are methods that, whoops, I accidentally pushed escape there. What was I saying? Oh, these double score before and after, these are special methods in Python, and there's nothing really all that meaningful about them except the double score before and after just signifies to those of us who use Python that it's a special method that shouldn't be messed with. You don't want to write your own user-defined function that would change this. So we're going to deal with one of these special methods today, and that's the double underscore init method. Okay, so this init method is known as a constructor because it constructs objects. It knits them together. Inside the init, we assign values to the object's attributes. So we define those attributes. Let's consider something kind of nice, easy, and mathy first, okay? Let's say we want to define a point class where we just have XY coordinates. So if you notice, I mean, we could define a bunch of XY coordinates within with lists within lists. So we could have a list within Python and then have a bunch of lists of just XY, XY, XY within that list object. But we're not really making any attributes when we do that. That lets a user know that these are XY coordinates. So this init method is going to let us do that. All right, so our two required attributes here are X and Y because an X and Y defines a coordinate point. Okay, so let's look at the definition of this. This is just the first part of the code. We're going to create the class. So notice we begin with that class statement. This, of course, is a keyword within Python. We're calling the new class that is user-defined point. Okay, it's going to create two-dimensional points. That's our comment. Within that, we're going to define this function where we just say, remember, this is a constructor function. So what it's going to do is it's going to point to or create this two-dimensional point for anything that it's run through. Okay, so self, which is the kind of internal local name here, dot x becomes the x coordinate, self dot y becomes y. So yes, we're just defining it, the first kind of null value as 0, 0 on the coordinate plane. It doesn't have to be, by the way. You'll see one where it's not 0, 0 in a moment. Then we can do this. So I wanted to make sure you could see how we actually use this now. So everything is done up here. Here's our class, and here's what we do to define these two-dimensional points within the class. Okay, so all we have to do, if I want to create a coordinate pair type object that is of class point in Python, I just say, okay, P1 is going to be assigned point. I don't put any values in there. I just say it's this. Okay, I could print, if I printed this out right now, it would, I could print p1.x, p1.y. Oh, well, just like occurs down there. It would have the value 0, 0 at this point. But then we can replace those values. We can do p1.x, replace it with 3. p1.y, I'm saying replace, but we're actually adding in 4 because we're starting at 0, 0. And then I can define another point. So I'm just very generically calling this P2. P2. I only replace the x coordinate for P2. So when I print these out, what should we get? Make a prediction. Okay, for P1, you should get 3, 4. For P2, you should get 4, 0. Okay, make sure you understand why. All right, so now practice this. Take a moment, just see if you can figure this one out. All right, did everybody choose A? Okay, notice all we printed was P2, so all the P1 stuff was a distraction, not relevant. And A is the correct answer. Okay, so we don't have to just define 0, 0 as the kind of null initial point, starting point. A point can always, that always starts at 0, 0 may not really be what we want. We may want to be able to specify more directly. So we could change, notice this is exactly what we had on the last slide or 2 slides ago. Instead of just having the object self, though, that is that local variable for the object that is of class point, we also have the coordinates x and y. So then it automatically defines those. So then I forgot to put the 1 here, but you can create a point just using a statement like this. My initial points are going to be the coordinate x equal 2, y equal 5. Okay? Then p dot x, p dot y will have those values 2 and then 5. Okay, I just saw I'm way out of time. So we're going to stop there and we'll pick back up using these in the next set of notes.